Good morning, afternoon, morning to some, afternoon to others. So, day one of this virtual learning experience. So, what you're going to do for me is today we're going to start off, we're going to open up this work power potential energy review. Just do a little brief review of things we talked about since we haven't had school now. I didn't have it Friday, didn't have it Monday. So now we're starting back on Tuesday. And so we're just going to do a brief review of that. After that, we're going to take some notes. And then you're going to have a homework assignment to do tonight as well after we finish up all those notes. So we're going to start real quick, like I said, review of this. So your classwork today is this, and you got to take notes. Now, you're going to take notes on your own. You're not sharing your notes with other people. If you do, points are coming off. I want you to take your own notes, okay? So you can write them down. That's fine. You can take them on Google Docs, share that with me. That's fine. If you write them down, take a picture, text me, email me, whatever you need to do there. And then, like I said, you're going to have a homework assignment tonight. Hey, if I were to guess what's probably coming up on Friday, hey, we'll probably have a quiz. I know this isn't going to shock anyone, but we're going to continue having quizzes as we go. And so we'll make sure that we're ready and set with that. And so that's just brief overview of what we're talking about as we got things coming up here. So today we'll finish kinetic energy. Tomorrow we'll start to get into conservation of energy. Probably spend Thursday going over some of those problems. Then Friday we'll take a quiz. Next week we'll get into it. Probably test towards the end of next week on all of energy, all of work, all of power. So just wanted to give you guys a heads up on that. But before we do anything else, let's just pray. Dear Lord, you're awesome. You're amazing. And as we get going on this new experience, as we get going and make sure that we just have this going on, just help us to stay focused, help us stay on task, help us to continue to learn. Lord, you've given each and every person such great abilities. Each and every student at Lutheran East has talents, has abilities that you've given them, you've provided them with. We just ask that you just continue to bless them, just help them to continue to grow in knowledge in all their subject areas. Lord, as this world has been turned upside down by this virus, we just ask that you just continue to bless, continue to comfort, watch over, heal, strengthen, and just watch over all of us. Be with our families, be with our friends, that hopefully none of them get this nasty virus either. Lord, you're awesome, and you are who we need to look to during this difficult time, during this time where things don't always look great. You're the one, you're the rock, you're the person who came to earth, lived perfectly for us, and died so that we can have hope. The hope of forgiveness of sins, because even though we mess up, you forgive us daily, Lord. The hope of eternal life in heaven with you. We just ask that you just continue to watch over us during this time of unknown, to get the best out of this time of unknown, and just continue to always grow closer to you. Lord, we want to thank you for all that you do. All this we lift up to you in the name of your great, glorious Son, Jesus Christ. Amen. All right, so also a lot of days I'll probably have a short little Google form out there, just a couple questions about notes, questions about things I talk about throughout the class period. So be aware and just ready for that. But without further ado, let's get going on this. So here we go. So it says, what is the equation to find work? And most of us know the equation to find work is going to be work equals force times distance. All right. So now just keep in mind, it says, what are the units for all of these parts? We know that work is going to be measured in joules. We know that force is going to be measured in newtons. We know that distance is going to be measured in meters. Now, as we go through, there will be times that I say, hey, pause it, try it by yourself. There will be times where you should just do that because I'm going to forget. Okay, so as we're going through, you should be able to know these things at least before we get started. Problems 4, 5, 6, you should be able to do as well. Bear with me as I plug some things into the calculator because you guys aren't here to answer questions for me, and so I'll have to go through and find them as well by myself, make sure that we're all right and we're all working on it together. As we're going through, if you have questions on anything, that's what that time period for you is going to be about. So FaceTime, we can do a giant FaceTime, we can do a Google Hangout, we can do all of that stuff to make sure that we're good and we know what's going on. And so just bear with us as we go through those things. All right, so question number 2, try and figure it out. As you do, press pause real quick. Bet you thought you pressed pause, but really it was just me pausing for a second. But anyhow, so here we go. What is the equation to find power? We know that power is going to equal work over time. All right. So power, remember, is measured in watts. Don't forget, a lot of times, hey, this W would be italicized for work. This W is not. Work there is still in joules. Time is in seconds. So we got watts that are going to be joules per second as we go. All right, next one was the equation to find gravitational potential energy. We said potential energy was equal mass times gravity times height. Said the things it depends on is the mass and the height, and then we also got gravity in there. Since potential energy is an energy, it is going to be measured in joules. Mass, we know, is going to be measured in kilograms. Gravity, of course, we know the value of that is 9.8 meters per second squared, and we know the height is going to be in meters. So that's what we have there. Fantastic. So that 1, 2, 3 should be pretty easy. Quick little review of things that we have talked about so far this unit as we continue to go on with different energies. All right, so let's scroll down a little bit, make sure that we are ready to go here. All right, so now let's do a couple of problems in relationship with these. So we're going to do some problems in relationship here. All right, so here's what we have. So number 4 on this document that you have, if I push a box with a force of 10 newtons for 3 meters, how much work is done on the box? All right, so what are we trying to find? We, of course, are trying to find work. So pause it for a second, try and find work, come back, see if we're right. All right, so here we go. Work is going to equal force times distance. I did not let this dry long enough, so let's try and get this a little drier. So work equals force times distance. We know our force, of course, is 10 newtons. We know our distance here is 3 meters. So real simply, 10 times 3 is 30, and we know work is measured in joules. So that one, we have 30 joules is my answer there. All right, so number 5, if Jaron and I are both doing 500 joules of work, I do it in 10 seconds, Jaron does it in 8 seconds. What is Jaron's power? What is my power? Does it make sense? All right, so does this answer actually make sense? All right, so let's talk through. To find power, we're going to do work divided by time. So we have 2 works and we have 2 times here, but we said, hey, we're doing the same amount of work. So we're both doing 500 joules. We're both doing 500 joules. Let's say, hey, this is Jaron, this is Mr. Jabs, okay? Great. So I do it in 10 seconds. Jaron does it in 8 seconds. So real quick, let's actually just take and let's find those answers. So we're just going to do 500 divided by 10, which I don't even know why I'm plugging this in a calculator, but I did anyway. So we got 50 watts there for me. All right, Jaron, we're going to do 500 divided by 8, and we get 62.5 watts. Does it make sense that Jaron uses more power than I do? The answer should be yes. Why should the answer be yes? The answer should be yes because what? He takes less time than I did. So we did the same amount of work. He did it faster than I did. So of course he used more power because he got done before me. So yes, Jaron should have a higher amount of power than I do because he did it faster than me. Hopefully that makes sense there. All right, we got one more example to do, and then we're going to get into some notes. All right, and so number 6, it says, hey, what is the potential energy? What is the potential energy of an object that has a mass of 20 kilograms and is 5 meters high? And so here we go. Potential energy, remember we just said was mass times gravity times height. I know the mass is 20. I know gravity is 9.8. I know the height is 5. So we're going to do 20 times 9.8 times 5. So we got 20 times 9.8 times 5. I'm going to get out 980 joules. because remember, energy is also measured in joules. Why? Because work is the ability to do energy, and energy is the ability to do work. So since energy is the ability to do work, we know that energy and work are going to be measured in the same thing. All right, so there we go. That's just a real quick review. Work, power, potential energy. Today we're going to get into kinetic energy. Remember, potential energy is stored up energy. Kinetic energy is going to be energy due to motion. So let me pull up our notes here. Like I said, you're all doing your own notes, so don't rely on other people. Otherwise, you won't be getting full credit for it. All right, so give me a second. I don't know, is this actually going to go to the right slide? Hello, go. Nope, not the right slide. So let's get to the right slide here. All right, okay, here we go. Kinetic energy. So if I were you, you guys know this, I'm not going to pause a lot. So if I were you, hey, if you want to get this down, pause the slide real quick, get the notes down, and then listen to what I actually have to say. All right, so I will get out of your way, and if I don't get out of your way, hopefully you guys can actually read everything up here. If that's an issue, please let me know, because I don't know if it's going to be an issue or not. I might try and watch them back, but I'm not going to watch all half an hour of my video back every single day. All right, so here we go. Energy of an object due to the object's motion. So what is kinetic energy? Hey, I'm in motion, right? So I'm moving. As I'm moving, I know we have kinetic energy. Fantastic. All right, depends on an object's mass. So I'm big. Other people are not as big. If we are going the same speed, I, of course, am going to have more energy because I have more mass. You have less of the mass, you have less energy, right? If I'm going the same speed as someone else and we run into something, I'm going to cause more damage. That's how you know I have more energy. Okay, as long as your velocity is the same, that's what we were just talking about, running together. There we go. It depends on an object's speed as well. So we know it depends on two things. It depends on the mass, it depends on the speed. So far, we have a mass and we have a velocity, and we know that kinetic energy is going to depend on those two things. So let's talk how they are actually dependent on that. We're not going to go full out into the units of everything. We know that kinetic energy, of course, it's an energy, so it's going to be measured in joules, but we're not going to talk, hey, all the logistical stuff about why it is that. Okay, so it depends on both mass and speed. That's what we've already mentioned. All right, next thing we have kinetic energy equals 1/2 mv squared. I know it's written out in words there. Up to you if you actually want to write it. But we have kinetic energy equals 1/2 mv squared. Now, a couple of things to keep in mind. Order of operations always tells me to do what first here? Take care of that squared before you do anything else, please. All right, so we're going to square that first. Don't try and multiply all this and then square it. You're going to get a wrong answer. All right, we know it's going to be measured in joules, so you guys should be okay with that. All right, hopefully we're all right. Going on, let's actually start some problems here. Your homework tonight probably will have some of these problems on it as well. And so then tomorrow we'll probably do a big review of kinetic potential energy problems as we go. All right, so here we go. Continuing on with kinetic energy. Before we get into any of the other stuff, all right, let me get out of your way here for a second. So think about, it depends more on speed than on mass. Right, so if I think about how much more damage there is in a collision when cars are fast compared to slow, the faster you go, hey, you hit that thing, it's going to be trouble, right? I've had situations before where I stop, I think the person in front of me is going, they inch forward, I accidentally bump them. Is there always a situation, is there always damage there? No, because I'm not going very fast, and I'm going so slow that I know there's not much energy. If I would be going 20 miles an hour, boom, damage would be done to our cars. But if I just tap them by going really, really slow, not going to be the case. Please don't hit other vehicles. Not a good idea. All right. Atoms and molecules are always moving. We said that. Even when they are solids, they're tightly packed, they're moving a little bit. And so since they're always moving, we know they always have this kinetic energy. And remember, if they're going to be higher kinetic energies, they're probably moving quicker. And if they're moving quicker, it's probably going to be a gas compared to a solid, which we know are pretty much locked in place. All right, so all particles have kinetic energy. We know that if I am going to be a gas, we're going to be moving quicker. And so that would be the case there. All right, good. Let's go through some examples. Now, example number one is a little tough. All right, so as we look through here, it's not bad at the beginning. The issue is really this 42 kilometers per hour. All right, why? Because when I'm talking velocity, let's talk our units real quick. Mass is going to be in kilograms. Velocity should be in meters per second. All right, so first thing I got to do is I got to change it to meters per second, and we'll talk through how to do that. But to find kinetic energy, we're going to do 1/2